Hello, class. Man, how y'all doing? I'm a little late. I was talking to my boss. Hello?
Hey, Professor.
Hey,
All right.
Professor. Green.
All right. Somebody's out there. Okay, let everybody connect real quick. Mm-hmm. Okay, got 12 people on. All right, anybody got any questions about the test? About the assignments? Hello, test assignments?
No, sir.
Okay. All right.
I have a question, sir.
Yeah.
For the solo learning, do you just want us to like take a screenshot of, you know, the stuff we've done, or like how do you want?
Right. I think toward the end, they're going to give you the modules or say the modules completed. Right. Just take a screenshot of that with your name, in the top corner. And right. And just submit it. Right. That's it.
Okay, sounds good.
All right. Where are we? Like I say, hopefully you don't have any questions about the test. Let me share my screen real quick. So I had a question about somebody asked me a question about programming. They said, "Oh, Mr. Vessel, I want to learn some programming." And like, "Oh well, copying and pasting is fine, but I want to learn. All we gonna do handwritten." I'm not gonna say we're gonna do handwritten programs, but I'm gonna give you programs that you got to write out and figure out and debug and whatnot and get the results. So hopefully the class gonna become more challenging. I just like to teach my class to where I give you what you need so that when I let you go to start doing your work, you understand pretty much what's going on. Because in computer science, if you ever taken computer classes, many instructors, and like I say, that's their teaching style. An instructor may talk about what you need to do. They may talk about, oh, you need to load this software, talk about whatever, and then say, here's your work, do it. And then you miss a click here, a click there, or one little, say, sentence where you have to do something, and you don't even get to either complete a phase of something to get to programming. But like I say, this is my teaching style. This is how I do it because I can't teach just one person. I got to teach the entire class. And hopefully the entire class can move along and understand and get what they need to get to the next level. But I do understand at times we have people that are more advanced than others. Cool. Hopefully you can do whatever it takes to stay focused and stay on path because I have to teach everybody. I can't just come in and say, oh, we're going to go through this chapter, boom, 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 do this, which I kind of roll through it, but I try to give examples so that you won't be so much confused, confused. All right. But like I say, we'll work with whatever we have to work with, and hopefully everybody can be satisfied as we go through the semester. So let's look at given that. Let's look at the assignment that I think I might have assignment for you in chapter 2. Let's see, chapter 2. So let's look at chapter 2 assignments. So I haven't posted them yet. So I have a string assignment, a second string assignment that you're gonna have to do, keyword assignment that you're gonna have to do. I'll post it. An assignment with escape sequence, you're gonna have to do a second one, and then you're gonna have the chapter assignments. All right. So let's look at the string program. This string program, simple program. All right, I'm about to download it. I'm gonna put in download. All right. This program simply says, all right, to write a program that will declare. So you need to know what declaring a variable is. Declare and initialize. Initialize means to give it the value when you assign when you are giving it the data type. For each question listed below, what is your name? So you have to have a name variable for that. What is your where do you live? You're gonna have to have a variable for that. What state do you live in? So you have to have variables. When I say variable, yeah, you have to have. Well, you won't have to have variables because yeah, you're gonna have to. You're gonna initialize it. So you're gonna give variable names like my name is whatever, whatever. Now, once all those variables are given values, I want you to exactly like this is. So you have an inline here, inline here, inline here, inline here, and another inline. So, hello, my name is, and you're going to output your name, period. All right. I am from city, comma, state. You're going to output this. You're going to output the comma. I'll take off if you don't, but city, okay, because you're reading in the city and you're reading in the state. Or not reading it in, but you're getting it from the variable that's initialized. All right. I enrolled at BRCC, whatever that semester was that you initialized, whatever year, all right, with a space in between. Okay, period. Major, whatever your major was, okay, is my major, period. New line, I plan to work as a whatever job that you said that you wanted to work as. And then once I have completed my studies, period. Now, it tells you variables must be declared as string. If you use string, you will need to use the string header file pound include string. That's one program that you'll have to do. All right. The next program will be similar to that program, which means you're going to get the same exact results or should get the same exact results if you give the information. All right. But you're doing it a different way. This program says write a C++ program that will prompt a user to input answers to the following questions. So now your variables don't have a value until what? You are prompted to give it. Some people, what they'll do, they'll give me the first program for the second one. That's wrong. That's the wrong program. Because even though they give the same results, you write them in a different fashion. Okay, so you're gonna prompt the user, what is your name? Then you're gonna have to prompt them to input their name. Prompt them, where do you live? Or what city do you live in? Then you're gonna prompt them to input the city. All right. It gives you hints down here. Remember, variables must be declared as string. Okay. Research the get line command to correctly display entries with spaces between words. What words? If you live in Baton Rouge, if the state is New York, New Space York. So stuff like that. That's why it tells you to research the get line. All right. So it says if you're using string, you will need to use the string header file, pound include string. All right. And then it gives an example of the get line command. All right. So, but then still research it to understand what's what. All right. So that's another assignment that will be posted after class. The 20 commands. What I'm asking you to do using Microsoft office, all right, because it should be a doc file. Okay, number and list the name and purpose of 20 different C++ commands or keywords, all right? And I gave an example to start off with. Commands purpose. The command number one, command is see out. What is see out used for? It's used to display output to the standard output device, i.e. monitor. Period. That's it. I don't want a paragraph of information of what that command does. Just a small, brief explanation of what it is. So you may have to read through the explanation that you get, or sometimes you may get a small, brief explanation of what it is. Okay? And then you number them to the next one, whatever. That's a small assignment, but you need to do it. Here, another assignment that you're going to have to do. Write a program using one cout statement that will output the following. Now, if you look at these quotes, these are double quotes. Normally with what I want to say, with a word processor, they got the open and close double quotes. But these are just the regular double quotes. But I want these double quotes, just like you see this output. That's what I want outputted. Now, some people what they'll do, they'll miss class or not come to class today, and they're gonna try to write this code, and they're gonna get errors because there's certain things that you got to do in order for this to happen. Okay, so and look what the note says: review your escape sequences. So you're gonna need to understand how escape sequences work and how to be able to print escape sequences. You got to know what are the escape sequences and what they mean. All right. So that's another assignment. Are they long? No, they're not long. They're hard. They could be complicated, depending on what method you take to solve them. Here's another one. Using a single cout, one cout statement, write a program that will produce the following. So these are very small programs, all right? This is a program that have a cout to output that. All of this, not just pound or you call hashtag to hashtag. I want the double quotes printed and everything else in between, and then double quotes. Any questions? Anybody have any questions? All right. Huh? Somebody?
Oh, I'll say no, sir.
Okay. All right. In chapter 2, once we get toward the end of it, we have this program. This says write a program given the length. So what? These are known values. I want you to use these two values. So a variable going to be of the length or the value 73, and the other value going to be of 49, and that's inches. It says convert the number of inches, okay, the total number of inches, because what you're going to do, you're going to add these two, and you're going to get a total, all right? And these two, the total going to be 122, all right? So you're going to compute it and calculate to get a total, and you're going to get a total of 122, my fault. All right, then I want you to, convert the number of inches of the two distances to feet and inches. So now you're going to come up with derive a way to come up with the 10 feet, 2 inches. Everybody understand that? So we'll look at stuff in reference to that. But you got to write that code. I just give you the problem. And then the last one is, given this is you can say this is an expression. All right, this is an expression. You need to solve it. Like normally in math, you need to solve this. So you can say X is equal to whatever this is. So write a program, a C++ program, to solve the following expression. All right, example, 2A is really 2 times A. minus 4b is really 4 times b, plus 3ab is really 3 times a times b, and 5a is really 5 times a, and 2b is really 2 times b. So you looking at this expression, you're gonna have to rewrite it into where the compiler gonna understand it, okay? And then solve for it. Given A to be a value, B to be a certain value, and C, well, no, I have C, just A and B. So if A was 0, 2 times 0, 3 times 0 times whatever B is, 5 times 0. You understand? And if B was 1, that would be 4 times 1. This would be 3 times A was 0 times 1, which was 0. 5 times 0, and then 2 times 1. All right. So you're gonna have to write that code, write the code, given A gonna be a value, B is gonna be a value, and then it's gonna solve and you're gonna output the value. Small programs, you start, like I say, I try to start out small, but they will get larger. But if you can understand this, you hopefully won't have any issues as we move along to more complex programming. All right. So those are the programs. Now, any questions before we get to the notes? Any questions? All right. So let's get to my notes.
Not really a question. I just wanted to apologize for not making class last week.
Oh, no problem. But you was able to do the work and take my test and whatnot?
Yes, sir. I didn't get as much involved as I should have due to complications, but I was able to get them completed.
All right. Okay. All right. But you understand why? Because I graded them. I don't think I graded number. It was one assignment I gave you or two. I think it might have been one. Yeah. But did you understand the assignment? Like I said, it was to just type it in. But I wanted you to get the experience of using that compiler, getting errors or whatnot. And now I gave you these numbers. You should be more comfortable with what? Creating a file in Visual Studio, compiling it, typing it in, compiling it, and getting the results. But if we'd have just started the first day, boom, write this program, then I'd have been getting all kind of emails. Oh, Mr. Vessel, where do we start? What do we do? How do we go about? Oh, I need the YouTube. And I think that's unnecessary stress when I can show you the process that we're going to be following throughout the semester. This is what we're going to be doing. All right.
Yeah, I will say in the end, I did wind up using Visual Studio a lot more confidently.
Right. Okay. All right. So let's move down to chapter 2 because we've done chapter 1. So let's look at chapter 2. These are, and I happen to get here. See what this says? C++ plus keywords, right? How many of these you need for your assignment? Nobody was listening.
20.
20.
20, remember? Because we use C out. So all you got to do is try to Google what that command means in C++. Google what that command means in C++, right? So that's gonna say that's your keywords that you can choose from. So let's get to. I don't want to. Let me see. I'll find it. All right. Oh, hi. I'm trying to get to the top of the chapter, but I'm getting to some of the sections that we kind of talked about prior to getting started. Look at this. Common escape sequences. Remember you had that assignment, right? 2 assignments dealing with what? Escape sequences, correct? Escape sequences are normally used within double quotes. All right. When I do see out double quote something, I can add an escape sequence within it. Give you an example. You know we use the NL at the end of a statement, right? I mean, this was my other class. Let me do this. So you know we use NL, right? To go to a new line, correct? Hello? All right.
Yes, sir.
All right. So now, looking at this program, if I run this program on this side, I'm gonna print this out, new line. Print this out, new line. Print this out, new line. So what? Everything will be printed on a line by itself. I run the code, and it gives me what? Each one on the new line, correct? Now, I can rewrite this by simply doing this. What it say? \n is a what? New line, right? It causes the cursor to go to the next line, all right? So now, if I do this, remember I said it has to be incorporated inside of double quotes. I could take this off and put \n, and now, rather than using inline, now I'm using \n. These characters, well, that's the \n is a non-printable character. So watch when I hit when I debug it this time. Exact same output, correct? Everybody see that? If I wanted to double space, I'll just simply add another \n. And that's going to be only for the name. It's going to double space between the name. Everybody see that? See a double space after the name because I had one \n, then the second \n, put the cursor here. All right? Now, we have \t. \t is a tab. It allows me to tab over and then start printing. So what? If I do a \t at the end, you won't see anything. It's just tabbing over to get to another space, but I'm not printing nothing because it's then going to a new line. But if I do a \t here, all of a sudden, Kate will be printed at the very beginning of the left margin, but 1, 2, 3, 4 Walnut Street will be tabbed over five character positions and then printed. So let's run this and see, debug it. Let's take the double space out. All right. And now it's just single space. And let's debug it now and watch. See that? Oh, no, it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. The ninth position. So what the \t did, it tabbed over, allowed my information to be shifted over, all right, by a tab, okay? Then you have \a. Well, what \a does, I put \a, and all it does, it gives you an alarm. And when I run it, you should hear a little ding noise or whatever once it compiles. Did you hear it? So it was a noise that was an alarm noise that was given when it hit. Right after it tabbed, it gave the noise, and then it ended. All right. So that's all that happens there. All right. Now, \b causes the cursor to go backwards. \r, it's like a carriage return. All right. Cause it to go to the beginning of the current line. A lot of times that we're not using this with our computer output, because normally computer output, you want it to just run, line by line by line. But these, look, if you had a carriage on like a typewriter and stuff, it stay on that same line, do whatever and whatnot. All right, \\, prints out one \. So here I got \n, right? But if before this I put \\, so what? It's gonna print out KATE space AUSTEN. Oh, I hit a \. I don't know what that is. Oh, it means I got another \. after, so it says I want one \. Because what? I got a \. here. Oh, what I'm gonna do? Oh, I'm gonna go to a new line. So the first \. signifies, wait a minute, let's see what's gonna happen. And then based on what's after it is what's gonna be done. So right here to print out Kate Austin, one backslash, and then go to a new line. So I'll debug it. All right. And it's gonna print what? The backslash, and I'm in a backslash, go to a new line, and then start the next one. Right? So, but the thing is too, you got to know the difference between a backslash and a forward slash. A forward slash is just like the divide symbol, same key. Backslash is the normally the slash above the return key on your keyboard. Okay, so you got to know the difference in the two. If I want to print a single quote, now some compilers by default you don't have to do it, but it just depends on the version of the compiler. You don't need to put the backslash to do the single quote. The double quotes, notice everything here is in double quotes. So if I wanted to print out Kate Austin and put Kate Austin in double quotes, I would have to what? First of all, write out this Kate Austin, but then I want to include backslash double quote. So it's going to print out that double quote around Kate. And then before I end it, I want backslash double quote. And that's going to print Kate Austin in double quotes and then go to a new line. All right, debug it. See, double quotes, Kate Austin, double quotes, and then it goes to the next line. All right, so that's your escape sequences. All right, now let me see if I get to the top of the notes. Okay, so yeah, here should be the beginning of the notes. Let me go ahead. All right. So chapter 2, okay. Parts of a program, we kind of looked at that prior to. Let's look at this program here. So this section is explaining this program, which we kind of looked at on last class period. The very first line, // which is the forward slash, a simple C++ program. This is a comment. When you see the // that signifies that it's a comment. If it's at the very beginning of the line, everything from that point on is commented, okay? So what do I mean by that? If I have these statements here, all right, and I put a // here, everything from that point on is a comment. Nothing will be executed, all right? But I can do that anywhere in the program, all right? I can have this information here, all right? And then what I can do at the very end, // and comment, whatever I want to say. Tell it why I'm using that statement. But everything from that // on is comment, but it doesn't affect the first part of that line, okay? That's a single line comment. Now we have our library. You're gonna always have to load some type of library when you're running C++ programs, because you're gonna be either doing some type of input, some type of output, or some other type process. So you're gonna have to load some type of library. The library we load here is the IO stream, input output stream. So #include and then IO stream. Now remember, in your programs, you created your own user-defined header file. So what? When you want to load your own header file, it's #include and in double quotes the header file name that you created. All right. So because you can have multiple header files included in a program. Then you have using namespace std that loads a standard library. But then every C++ program has a main function. Here is the main function. A function, it has a function header and a body enclosed in open and closed curly braces. All right? So if you look here, the body of this main function is cout, and it's streaming to the console, Programming is great fun, exclamation point, close, double quotes, semicolon. And the return 0 just says, okay, it successfully executed because it reached this point. All right. And that's a small program. All right. That's a small program. And now it just tells you all of what the different parts of the program is. And we went over this already. And you can read through it to get a better understanding, but that's a small program. Now, it tells us, it gives us certain characters that have special meaning, all right? Well, at the slash, not backslash, slash, or the double slash marks the beginning of a comment. We talked about that. The pound symbol, or the you call hashtag, marks the beginning of a preprocessor directive or where you actually loading your header files. Then you have the opening and closing brackets around the actual header file that you actually loading, okay? Then you have open and close parentheses, which groups a functions or the arguments of a function. And right now we don't have anything in our main function because we're not passing anything or variables or whatnot, but we're going to get to that. And then you have open and close curly braces, which are used to define the beginning and the ending of a body of a function. You have your double quotes, which enclose a string of characters. And then you have a semicolon, which is not used at the end of every C++ statement, but is used at the end of some C++ statement, all right? So you got to be careful. You got to know when to use it and not to use it. And when we get to if statements, I'm going to show you how you can use it, and it doesn't give you an error, but it causes all kind of havoc, all right? So you need to review this, all right? The cout statement. It tells us the cout object, all right, use the cout object to display information to your computer screen. And what? When we looked at this program, what? We had what? Cout Kate Austin. Well, we had backslash. That just told us to put this information onto the console. Send this information onto the console. Send this information onto the console. Cout, console out. And what? Stream it or send it to the console. And that's what happens. It printed that output. Okay? Any questions? All right? And look, there's just an example of what's going on. All right, to the console. Stream object, all right? The stream object cout, and it's gonna output this information. All right? Still the same program, but what happens what's the difference between this one and the other one? The other program, it didn't stream two different parts of strings. The other one streamed everything at one time, but this one broke it up. Now, I'll show you how, okay, in here, I could output Kate, all right, and then stream Austin. It's gonna work the same. All I did was broke up this string to print out Kate space and then Austin. But well, I'll run it this way first and show you. It's gonna give me the exact same output. All right. So, right, my computer was running slow. So it gives the same exact output, right? Kate Austin, tab, print that, this, and in double quotes, all right? But you gotta be mindful because when you start doing that, if I don't put a space after the E, I'm printing out KETE, then I'm streaming out AUSTEN, where what? All of a sudden now, it's like if I was reading something, it got Kate Austin as one whole word. So that's why you, like I say, putting that extra space at the end. Now you could put it on either one you want. You could put the space here, or you could put the space here. It doesn't matter. Some people say, well, Mr. Vessel, why do it that way? Can we do it this way? All right, you stream, and a stream of space, you can do that. I'm streaming KATE, then I'm streaming a space, then I'm streaming Austin. Same difference, all right? But you can reduce the code by either just adding a space inside of this one. But like I say, either one will work. They'll work the same exact way. And a lot of this is programmer style, all right? The programmer style. All right. Now, look what they did here. Get the same results. See out programming is, and then you ended it, but you didn't put a what? An inline. And then you got see out great fun. So what? When you output it, programming is, the cursor stayed right here. And then when you see out great fun, then it continued on to output the remainder of the second see out statement. Not until it see a \n or inline will it return to a new line. Okay, so you got to remember that. All right, so this just give you some examples. In this code here is outputting this information. But what happened? At the end of each one of these statements, there's no what? There's no inline. So everything is being printed what? All together. Between sellers and during, there's no space. Between June, the colon of June and computers, there's no space. And then at the end of games and coffee, there's no space. And at the end of coffee and the beginning of aspirin, there's no space. So it's just showing you this code, even though it doesn't have any errors, it outputs in a wrong manner, all right? So all of a sudden, given this code, you got an inline after each one of these see outs, meaning it's going to see out this, new line, 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 see out this, new line. So each see out outputted information on a new line. That could be what you want, could be not. It just depends on how the output should be displayed, all right? So every time see out encounters an NL stream, all right, manipulator, it advances the output, all right, to a new line, all right, or to the beginning of the next line, which would be a new line, okay? Now, it says the manipulator can be inserted anywhere in the stream of characters, okay, set to see out, outside the double quotes, all right? So that means you could use this outside the double quotes. If I wanted to do something inside the double quotes, like I told you before, I could remove this and put \n inside of here, and it will still work the same, all right? All right. So now, just like we had inline, but inline cannot go inside the double quotes. We have to stream it by itself. But if we wanted to, we could not. We could have eliminated the inline and used \n inside the double quotes at the end of each of the statements and gotten the what? The exact same results. But all that would be considered programmer style. Some programmers would like to use the \n inside the double quotes. Some programmers like to use the inline being streamed. It's all up to the programmer because either one will work, all right? So, and like I say, it won't cause any issues with your program. So, and like I say, the new line escape sequence is \n, and we went over it. Now, look at this. Why do we have an error in this, anybody? Can anybody tell me why we have an error in this code here? Or is it an error? It's not you won't get an error, but there's a problem with the output. And who could tell me why there's a problem with the output? Anybody? What would cause the output of this not to be correct? Anybody? What happens is here, looking at
Brennan posted a /.
Right, correct. Right, and that's the answer. Because what? Looking at this, you're saying 4 and that should be \n. Otherwise, you're saying 4 and 7 years /n ago, or 7 years ago, /n. You got what I'm saying? So what I'm gonna do, I'm gonna take this. I think, oh no, I can't copy. Can I copy this? Yes, I can. I'm gonna copy this. All right, I'll copy this. And I'll do an inline here. And then I'll do a paste. All right. So see, I don't get any errors, correct? I don't get any errors. And I'm gonna just do a CL inline to inline. All right. So let's run this and see what happens with this 4 line. So we run it, and what? Everything gonna be on the same line with no spaces where you have the /n. So look, 4 /n. It's not a backslash, so what? It takes another regular character, the n as a regular character, and then and 7 regular character, the slash, and then the n. And this, and then look, slash, and then N and N. All right. So now, if I go back in the program and I do \, now when I run it, see, 4 \n, go to new line, and 7 \n, go to new line. Years ago, \n, go to new line, then I had inline. All right. So you see how using the \n, it can be confusing if you don't know what the / is or the / is. You gotta know the difference in the two. All right. Got you. All right. Oh, I need to go back here. All right. So now, and what I said was, it said error, but you don't get an error, you get the improper output, all right? So, looking at this, what is the problem with this statement? See out, double quotes, good, double quotes, close the double quotes, and stream \n. What's wrong with this statement? Anybody? The problem with this statement is you could solve it in 2 ways. I can put double quotes around the \n and solve my problem, and the double quotes around this one to solve the problem. Or I can put what? \n within and close within the double quotes and put a semicolon here and remove this. \n in here, semicolon, and remove that. Everybody understand that? Everybody got that? The way which you can change using \n or double quote. All right. So look what happens here. Rather than have it out here, they said what? We put it. We print out good, new line. It's all within the double quotes. All right. \n, which is an escape sequence, always go in the double quotes, and then morning \n. All right. So that's how you would use the escape sequences. And remember, we went over when we first got in, these are some of the escape sequences. All right. Now, what is showing here, this is how data is actually stored in the computer. We look at data as how it formats on the screen, but the computer just see the data all in lines, all in a line, continuous line. That's how data is seen by the computer, right? The directives, we said what? We will always have to load at least one of the directives so that it can load the library that's needed, all right? And so you'll have a directive loaded at the beginning, all right? Now, And you use the pound include to do so. Okay. Variables and literals. Literals. You should have taken what? The variable quiz, correct? Remember we talked about the variables and the process of naming variables. What were some of the rules? One was it has to be one word, one whole word. Let's go to the Visual Studio. So let's create a variable. What do we mean by creating a variable? What we're doing, we allocating space so that that variable can hold a value. What type data can be held in that variable? It depends on what data type we give it. So all variables has to have a data type. Now there are like the language PHP. PHP does not require you to give a certain data type. What it does is based on the information that you give, it'll take it and use it as the data type that it thinks that data type should be. But with coding and normally with programming and compilers, you have to give a data type and then a variable name as to what that variable is to be referenced as. Give an example. If I was to write a program that was to take three numbers, all right, and add them together, and then output the sum. So what you would need, okay, you got three numbers that gonna have three values, and then you're gonna have one number that you're gonna assign the total value to. So you're gonna have four variables in your program. So you may have int num1, or you could do it this way. I'm gonna show you. You could do it this way: int num2, int num3. All right. You could write your code that way, or I could have did if I wanted them all on one line, I could have done num2. Notice I use a comma, num3. So now either that way, cut my lines down by two, or have what each individual a variable on this line by itself. Either way. Now we said these, and then we had what a total comma, and I'll create a variable called total. Now we talked about the validation of a valid variable names. When you took the quiz, must be one word, no spaces. Must not begin with a number. A number could be anywhere else in the variable name except for the first character. All right. If I did this one, or even just one num, it won't work because it has a numeric value at the beginning of the variable. All right. So one word cannot begin with a number and no special characters. Remember, exclamation, pound, at symbol, percent symbol, and asterisk, parentheses, curly braces, question mark. Those are special characters. But I can use the underscore, okay? I can use the underscore. It is valid, okay? Because what? I can create a variable that pretty much is very, very descriptive. Like I could do something like this. Int total all right, totals of the three numbers, and between each word I have an underscore. So see, you could write a program to where your variables are almost like English, like sentences, and you read through them or whatever. All right, so that's valid. You can do that. All right, no problem. All right, but normally programmers, what they'll do, num1, num2, num3 total. All right. But like I said, when you start writing larger programs, you may want to be more descriptive of what your variables names are, so that you don't have to put so many comments to know what's going on in the program. All right, so write a program that's gonna add 3 values. All right, so what I'll do, this just declaring a variable, just giving it a data type, int num2, and int num1, int num2, int num3, int total. All that's doing is allocating space for integer, which would be an address for each individual variable. Okay. Now, when I initialize a variable, now I'm going to introduce a value. All right. Now, if I could type. Comma. All right, so now I have 3 variables that I declared, but I also initialized at the time I introduced them. All right, that's the only time you can initialize a variable, when you're actually allocating the space for it, giving a data type. That's initialization. So now, if I wanted to find out the total of those 3 numbers, okay, all I need to do is say what? Total is equal to what? What's an expression? Num1 plus num2 plus num3. So I'm adding up num1, num2, num3, and I'm storing the value into total. Okay. Again, as I told my other class earlier this morning, if you have an expression that you're trying to solve, that expression should always, I don't care what you do, always be on the right-hand side of the equal sign to be solved, and then assign to the left. So I'm solving on the right and assigning to the left. So look at total. Total is declared but not initialized, meaning it's not given a value at the time that it was declared. But look here, total equal. What we're doing here, we assigning a value to total. Okay, we've taken some values that we have in variables, and we are assigning it. This is not initializing, because what? The computer already know that total is a variable, and space is already allocated. So it wasn't initialized, but here the value is being assigned to total. So now what we can do, I'll just use one cout statement. Now we can see out. I'll leave the backslash in, and now we could see out put /2. Then I don't want to do an inline here. All right, and then I'll do a stream, if I can type, and then I can stream in what? Total. So now, it calculating the sums, sum of these numbers, storing it in the total, then I'm prompting the user the total of the 3 numbers are, and whatever the total is. So if I debug it, was that 7, 4, and 2, that's 11 and 2, that's what? 13. So debug this, and it should show me the results. So see here, the total of the 3 numbers are, and 13, all right? Now, this is one thing also that you need to remember, that if I make a mistake inside my double quotes, whatever I'm trying to, literal I'm trying to stream out, and I misspell total and I put TOTEL, that's what's gonna print. You understand? It's gonna print exactly what you tell it to print. See? TOTEL. Why? Because it got it from here. Okay, so sometimes you're gonna have to watch your spelling of your words within your prompt because it's gonna display it exactly like you gave it. All right, now so back to the program. That's variables. All right. All right. Now look at this. Look at this program. Int number. Number is being declared or initialized at this point. Anybody? Hello? Is number being declared or initialized?
Initialized.
Huh?
Is it being initialized?
No, it's not being given a value here. It's being declared.
Mhm.
So when you give the data type and the variable, you're saying declare this to be of integer and hold this space in whatever address for it.
So only when there's a specific number necessary there.
Right.
Okay.
Right.
Okay.
If I say int number equal 4, now I'm initializing it, giving it a starting point, a starting value. You got what I'm saying?
Yeah, I get what you're saying. Declare is
Right.
kind of like the beginning to okay.
Correct. Now, look at that next statement. Number equal 5. What am I doing now? Declaring or assigning? Or initializing or assigning? I'm assigning because if I was initializing, I would give it when I first introduced. You understand? When you give a value, when you first introduce the variable, that's initializing. But then when you use the variable after that and you give it a value or whatnot, that's just assigning. Everybody got that? I could have down here number equal 10. That's assigning. This is assigning. This is declaring. Okay? Everybody got that? So if I go back to this program, where is that? Yeah, int num1 equal 2. What I'm doing to this variable? Int num1 equal 2. What I'm doing here?
Initializing.
Initializing.
That's what Brennan said, by the way.
Huh?
Brennan said that.
Okay. Right, he's correct. Num2 equal 4. What am I doing? What am I doing here?
Is this initializing again?
Initializing. Num3 equals 7. What am I doing here?
Initializing again.
That's why I'm introducing at that time. Then we got in total. What am I doing here?
Is that gonna be no? Just declaring. Brennan said declaring.
Correct. All I'm doing is declaring it. I never gave it a value, so I'm not initializing. So I'm just declaring it, right? So when I get down to this statement and say total is equal to num1 plus num2 plus num3, what am I doing to total? The value is being what to total?
Is this one gonna be assigning?
Correct. It's assigning because I've already introduced it here. It's being declared. Now I'm assigning. All right. If I do this, num1 equals 10. What am I doing here? Anybody? It's okay to be wrong, you know what I'm saying? But and if you say you get, I'll let you know if you're right or wrong, and then we move on. So what we doing here? It's already introduced here, right? Correct? It's initialized to 2 here, right? So at this point, what we doing? We assigning, correct? It just overwriting the 2 with the 10. It's assigning 10 to num1. Everybody got that? So there's a difference between initializing as opposed to assigning, as opposed to declaring. All right? So, I don't want to be here, I'm over here. Okay, so, and it says, notice that the 5 has a semicolon at the end, and that's the syntax. That's the way you declare the variables, okay? And it says what? This is called an assignment because you don't have what in front of it? A data type. But what? These don't have a data type in front of them, but they all are part of this what? That one statement. You got what I'm saying? So these are being initialized, all right? Now, okay, and then it talks about what's going on here and the value. So sometimes a number is a number. Now, what does that actually mean? What it means is, if I go back to this program, and I'm gonna take all this out, and I can do this. I can do char. All right. Okay. So now, looking at this, semicolon. Looking at this program, I got num equaling to 5 and num1 equaling to 5, correct? Everybody see that? But if you really look at it, 5 here is the character 5. It's not the numeric value 5. So that's why they're telling you sometimes a number is not the actual number. All right? It depends on its data type. And watch, let's see. I'm gonna try to show you. And I'll say total is equal to num. And what? In looking at this, we should say what? 5 plus 5 is 10. So we should get 10, right? But 5 in single quotes is not 5. Everybody see this? See what happens here? See the answer I get? I get 58. So what happens? It took the character value of 5, which is an integer value, and then it added to 5 to that. So really, the character 5 is really equal to what? 53. Now you say, well, Mr. Bell, how you discern that? How you get that get to that value? Okay, let's go back. ASCII table. Go to the ASCII table. Pull up our ASCII table. If I can pull it up. Right. What did I do? Oh, okay. All right, so let's look at this table. I want you to be able to see. All right, so let's look down here. Look at the number 5. The character value of 5, right, in decimal is what? 53. You understand? So that decimal value for that character value of 5 is 53. But then if we go here, the decimal value of 5 is 5. So 53 plus 5, that's what the compiler did. It says, okay, it's adding. So I can't add a string, or not a string, a char value of 5. So I'm gonna find 5 in my table and get his character value of the string 5, and which is 53, and add 53 to 5 and get 58. Everybody understand what happens? Questions? So all it's saying is sometimes a number is not a number. And like I said, it all depends on what? The data type that is stored up in. Because if a character 5 is not the number 5. All right? Now, it's going to show you about a char of character and a string character in the notes. Let's get to the notes. All right. So we know that sometimes 5 isn't 5. So look here, double quotes. 5. So this would be a string. All right. And what happens is, well, it talks about it, and it tells us in line if 5 is no longer an integer, but a string literal, all right? Where you can just do cout 5 and then go output the string 5, all right? So what's a literal? A literal is a piece of data that is written directly into the programmer's code, all right? So what? This would be the literal, 100. Number equal what? 100. In this, today we sold, whatever's in this double quotes being outputted is a literal, all right? So it's saying one of the most common uses of literals is to assign a value to a variable. So anytime you assign a value to a variable, you're assigning that literal. It's a literal. That value that you're assigning, it's called a literal, right? And it's showing that, and it's showing this, all right? So it's saying what? Okay, this is an integer literal. So if I said what, x equal 20, you're assigning 20. Today we sold. I could say name equals today we sold. Name equal bushels of apples. So you could assign this to a variable. Okay, 0 is a literal, such as a number, x equals 0. All right, so literals are also called constants. What can 20 equal to? 20 can only equal to 20, right? It's a constant. So if I put in double quotes, today we sold space, what does that equal to? Today we sold. It cannot be changed. It's a constant. Now, if I change the O to an E, then I've changed the value to that constant to another constant. So whatever is in those double quotes is a literal and can be considered a constant. All right. Identifiers, and like I say, programmer identifiers are the variable names. Variable names must be one word, must not have begin with a number, and does not contain any special characters. So another key point for naming your variables is you cannot use any of these keywords as variables. Any of them. Say like if I wanted to use the word short, if I say int short equals 5, I'm gonna have an error because short is a reserved word. It's a key word that C++ uses. Or if I wanted to use any one of them, say if I wanted to use this, if I say float this equals 10. Nope, can't do that because this is already defined somewhere in the compiler to be used for something, and you will get an error. So you cannot do that. So I can do X, but I can do int X, but I can't do int float, int class, int extern, int operator. Can't do that. I'm gonna get an error. Look, valid name, items ordered. It's valid. One word, no spaces, and doesn't have special characters. All right? Why is this flipping? I thought I told you to. There you go. All right. So now, right. So, in items ordered. So let's see. This one is a capital O. This lowercase. These are two different variables. Remember we talked about that. There are two different variables. Uppercase and lowercase are different, okay? They are different. Okay, here's the ruling again, or the rules for your identifiers. All right, here are some valid. One word, yes. Does not begin with a number, yes. Does it have special characters? No, so it'll pass. Or has no special characters, yes. Okay, begin with a number, yes. Oh, so it's illegal. Okay, begin with a number, no. One word, yes. Special characters, no. Oh, it's good. Okay, begin with a number, no, it doesn't. Is one word, yes. Special characters, no. Okay, it's good. Begin with a number, no. Special characters, yes. So it's illegal. So you understand? So when if it doesn't pass those tests, it is illegal, and you will have issues with your programs if you try to create variables that are illegal. Okay. Now, data types. As you grow in the computer area, or in your computer world, your computer coding, you're gonna understand data types. What's a data type? A data type is the class or defines what type data a variable will hold. Okay. What are the two types of data? You can either have integer data or you can have, well, scratch that. You can have numeric data and you could have character data. Numeric data could be real, which is decimal places, or whole numbers, right? Real or whole numbers, all right? Integer, integer data can be of data type short, int, and long, and we got long int, short int, etc. But integer data types are whole numbers. Real or decimal data types would be a float or double, long double, whatever. All right. So you got integer, you got numeric data that can be of a whole number or either a fraction or a decimal point number. All right. Then you got character data that can be of a single character or a series of characters, a string of characters. All right. So those are the data types. Right. What type data that variable can hold. Okay. There are many different types of data. Okay. Variables are classified according to their data type, which determines what information that may be stored in them. Integer variables can only hold whole numbers. All right. Now, and I'll go over that and I'll show you a program that and test it to prove it. My program on it. So why they keep reading? All right, right. So, all right. Something going on my program. Okay. All right. So, okay. Look like you keep trying to read something as I go through with it. All right. So these are your data types, class. But I was trying to get the time. All right. So here are your data types. And this is for integer. You can have short int, unsigned short int, unsigned int, long int, unsigned long int, long int, and unsigned long int. Now, the unsigned, all that's saying is that the value of that variable gonna always be positive because there's no sign with a positive or negative in front of it. Okay, which makes you able to hold a larger digit in that data type. But like I said, no sign, so it always positive. Everybody understand it? And it's showing you the values of the range of values that can go in that data type. Okay, short int typically takes up 2 bytes of space. We'll get into the importance of that a little later on when we start dealing with arrays. Unsigned short int, unsigned 2 bytes, but it can only have what? Integer values. I mean, positive values, all right? Now, so, Might have to stop that. All right. So here are some examples of the variable definitions in days. So days enter the data type. Unsigned speed. So speed can only be what? Positive. You cannot have a negative value for speed. So that's when you have that unsigned, it can only hold a positive value. Say short if it's a positive value. All right. So that's all this is showing you. All right. Each of these data types, all right, except it can be abbreviated. All right, as follows. You got short int. Okay, you can just use short. Unsigned int. Okay, it can be abbreviated as just unsigned short. Int is the understood. So that's all they're telling you here. The int part is understood. Anytime you use short, it's understood as being integer data. All right. Now, so here, same thing here. And all these deal with this programmer style. If I say short month, it knows that it's what? Integer data type. Unsigned speed, it knows that it's what? Integer data type. So that's all it's just telling you. You could do it, you could use the short, you could use the int, it won't cause any problems, but you can also do it this way. And that's just all programmer style. All right, programmer style. All right. All right. So integers are at least as big as short integers. All right. What they're talking about here is, let's look at the short. It tells us that the int and long data types have the same size and range of numbers, all right, ranges, which means there's the values that can be stored. And what I'm gonna show you something. If you do something like this, and I'll have to go back and find that value. If I do something like this, short, and I'll say, and that's 30, I think it's 32. Let me go back to this, to the range. All right, see the range, the maximum positive range for a short data type or a short int is 32,767. So if I go here and put this here, all right, now I need to take the comma.
Hey, Professor.
Yeah.
Miss Haley has a class she needs to get to.
All right, man. All right, let me finish this and we go. Man, I'm just going on. All right, so let's look at this. And if I do a number is equal to number plus 1, and then we're gonna go. If I do this and then we output number, what you think that the total should be? What the total should be that I print out? Let's say number, yeah. Anybody? Ideally, it should be what? 32,768, right?
Yeah.
But being that the data type is of short, the maximum range is 32,767. So if I add 1, it's going to loop back to the very beginning of its range, which is a negative 32,000 something. So watch when I run it. Oh, it's down here. Look what I got. You got me? It's a negative. But, okay. Right. But what happens is, it being that the data type was the wrong data type, and it can't hold nothing larger than that value there. And if we look back at this, you see, it can't hold nothing larger than this. You see? And then it's going to loop back to the negative this. If I add another 1 to it, it's going to be negative 32,769. and it's gonna try to climb up that range again. So to fix that problem, what you would do is in the program, I'd say, okay, I'm gonna change this data type to int, right? And then I debug the program and I should get the right answer. See what I'm saying? So, and we'll get, like I said, the class is in it, but we have to understand the size of the values that we're going to be dealing with when we create our variables and give it the data type, so that we won't run into this type problem. Okay. So I done posted the programs. You can continue on through the chapter and look at data that's going to help you work with the programs. And like I said, next class period, I'll continue on, and depending, I might extend the latter programs to the next week. But you could go on if you want to just challenge yourself and try to do those programs. But what I'm gonna do, I'm gonna go ahead on and open those assignments so you can go ahead on and start working on them. So have a good day. Like I said, I'm sorry to keep y'all late, you know. I get at the end, I start running. I just going on with it. I'm sorry about that, but I'll catch y'all on the next class period. I'm gonna post those assignments. All right.
Okay, Professor. Have a good one.
All right.
Thank you so much, Sylvester.
All right. Okay, stop sharing.